we are going to discuss about the integration. Integration is nothing but a summation of the quantities which are related to a function. So which will come under the calculus. As we know, calculus involves the solving of the small changes, or otherwise the problems involved with the small changes. So before this we have completed limits, differentiation. Limits deals already you know when value is approaching to the given, and in differentiation we obtain very small changes occurred in a given variable. Now in integration we are going to find out the sum of the quantity. So sum of the quantity is nothing but a whatever he has given that we can divide into small laminas or small parts. As we are added, you will get the whole value. That is called as a integration. Integration is the inverse process of the differentiation. So also known as antiderivative of a function. So as you have completed the derivative, you are very well known about the differentiation. So now we are going to discuss about the integration. In meanwhile, you have to understand that it is an antiderivative. Means it is the inverse process of the differentiation. Students, commonly use just to let it in. Theoretically, you can apply yourself. If left to derivative is right, right to derivative is left. Like that you can understand. So easily you can able to solve. So an antiderivative of a function f of x is a new function capital F of x such that d of f of x by dx equal to f of x, or derivative of capital F of x with respect to the dx equal to small f of x. As we said, students, the left derivative will give the right. So automatically right integration will give the left. Now once more you can understand that derivative of capital F of x equal to small f of x. So if you integrate the small f of x, you will get the capital F of x. That is the reason the integration is known as antiderivative of a function, or also we can known as inverse process of the differentiation. Now you are seeing that in integration we have two parts. One is indefinite integration and another is the definite integration. What is meant by indefinite is nothing but here we are going to find the sum, but actually we don't know the what are limits. Here suppose let's some example 1, 2, 3, 4, 5. If our respected teacher asked us to find the sum of any 3 digits, so we can take as our like. Some we may take 1 plus 2 plus 3, some we may take odd numbers. So all will get the different answer. So the answers are what here? Indefinite. Because of here our respected teacher has not given any information to us, but given only the information, we need to add the only 3 digits. So that is why we have to understand here there is no definite intervals to us. That is why it is known as indefinite. So in indefinite integration we cannot use the interval. As we said, integration is nothing but a sum. So if we add anything, we must know from where to where we add. So whenever you don't know that, that is called as a indefinite integration. So whenever students you know the intervals, that is nothing but a limits, that is called as the definite integration. So you can see as a definite integration we have shown there in interval, otherwise in limits, integral x1 to x2 f of x dx. Here x1 is known as lower limit, x2 is known as the upper limit. Here the whatever the terminology that we are using in integration that we are showing here, Now see here, integral a to b f of x dx, as it is a definite integration. So we have given the intervals, those are known as the limits to us. So a to b, the function we are defining from a to b. So in which from a to b, whatever the region as given, that we are going to find. So now again you can see, as integral whenever you have taken students, as we said, integration is nothing but a sum of the quantities from s, means sum means sum, the s just you can elongate. If you elongate s, that is known as swoopy s, it is called as what here? Sign of integral. Here f of x is integrand that we are going to find. So which we are going to find is known as integrand. That is why as you are going to do the problem, so in some books you may see that GI means given integrand. Because of, for that only we are going to find out the what here? Integral of a function, that is called as what here? Integrand of a given. A and B limits of integration. A is the lower limit as we said, and B is the upper limit. Here dx is commonly we can take it as a dummy. So here commonly it is known as a parenthesis and infinitesimal, a variable. Students, as we studied here in derivative, so dependent variable can change with respect to the independent variable. So here is also whatever the integrand we are using. So the integrand we are going to calculate means with respect to the what here? Small takings. Small takings nothing but as before we said, the region we can divide in small parts. Commonly when you apply to the body, which are known as the tiny particles. Here we can take a small regions that we can show you by graph later on, that you can see. The process of computing an integral is called integration. Now as we said before, we can show it by a graph. So take x and y axis here, the sum of the areas, whatever the region is there with respect to the graph, so that we are divided into small parts. So each part you can take, so we have the many parts, that was the space whatever it has given, we divided into many parts, that is from A to B. Here if you want to know the area of the total region, that is nothing but a sum of the areas of all small parts. So each part you can see, those parts we are divided as a rectangle. So now the area of rectangle you know very well, length into breadth. So length nothing but a, you can see an x-axis. In interval A and B, as we have divided that line into the small parts, let them take as delta x. So each part you can take as delta x on x-axis. So when you projected, that is vertical efforts, that is represented by y1, the first figure for y2, for next to y3. Because of going on, what happened here? Curve has moved upwards. Due to that reason, the height has increased, which has taken as a y1. As you know, the area of a rectangle is length into breadth. The area of total figure, which we are taking from A to B, is equal to the sum of the all areas. The sum of the all areas by algebraic method, we can show it by a sigma. Therefore, the areas which are equal to approximately area equal to sigma k, yk, del x we can. Here k is nothing but a from where to where we can take, which can be represent. The definite integral as a limit, already before we have shown, if f is a function defined on a comma b, closed interval. Why closed interval we are taking? Because of those are included. As we know, we have the two types of the brackets, open, closed, and we can use the process. Here these two values are included. In definite integration, definitely the two can be considered. The definite integral of f from a to b is the number. Because of when you applied the limits, automatically you will get a quantity. That is why what we said, the definite integration will give us a quantity. Now you can see here integral a to b f of x dx also we can write as limit n reaches to infinity sigma I equal to 1 to n f of ci delta x. What is meant by this? Nothing but a, students, now we have shown in graph. So from a to b we can divide the graph into any number of parts. As that parts going on increases, the delta x will going on decreases, as before we have shown in a graphical figure. So length into breadth, whatever you have taken, as area of a rectangle we have taken length into breadth, that is delta x into y. When you are divided many number of parts, delta x continuously decreases. If you increase the number of parts, number of figures, number of small parts, just to simply understand that delta x becomes a narrow, delta x decreases. As n reaches to infinity means the number of parts which we have taken when you have increased, automatically the space commonly decreases. So that is why, students, you see here where delta x equal nothing but what is here, upper limit minus lower limit by n. So how many parts, as n is increasing, the number of parts increasing, the space automatically will decreases. So where delta x equal b minus a by n, and for each I, xi equal to a plus I delta x, and ci is a point in which is given, that is xi minus 1 comma xi. Exact area as definite integral. Integral a to b y dx equal to limit delta x to dx sigma k yk dx. Because of already we have shown in graph, the area is nothing but a y into delta x. Okay, students, all the best. We think that you understood very clearly. So once more revise yourself. Just it will give a clear direction for you to understand the definite integration easily.